Okay, welcome everybody. Let's get started. Thank you all for joining us today for another Tridium Talk. This will be the kickoff for the 413 feature overview series, which should indicate that we have a new major release coming, and we will continue over the next couple of months to provide these feature overview Tridium talks to showcase and highlight some of the new major features that'll be coming out with each release or with the upcoming release. So, stay tuned for each of these series. Be sure to come back later and watch these, as they're just great ways to provide ongoing training or sales pitch. Or if you're an end user and you see something you really like, you may decide to implement it on your site. So today's topic is the multi-tiered system database. I am Chris Riccobono, representing the product management team. And with me today are two veteran engineers, Scott Hoy and Blake Puak, who will be assisting with the whole Tridium talk. Scott is the, I'd say, is the engineer behind most of the work involved with this feature, and Blake is a software architect who guides us all along the way, and today he'll be helping us with some moderation for the Tridium talk. So we'll highlight what's one of my new favorite marketing collateral icons. This great pentagon represents, for anyone new to Niagara, this really, covers a vast majority of, what Niagara can do. And these five, categories represent what most of our features try to target in terms of evolving and progressing the framework. And so going over the agenda for today's Tridium talk, we're going to cover a little bit about what's new with Niagara, so everyone gets up to speed with where we are and in our release cadence. Then we're going to hit the feature, talk a little bit myself about multi-tiered system database, and then we'll roll into a demo where Scott will provide you with just a great presentation of the actual work at play. And then we'll wrap it up with kind of a nice reminder of where you can find additional resources and materials to just learn about the framework or this topic in general. And then we're going to end it with the Q&A. And so for those that are new to our Tridium talk, there is a Q&A button. You're able to ask questions at any time. We'll be, during the presentation, we'll be covering some of the questions in just the chat. If there's a question in particular that seems really educational for the topic at hand, we'll cover that in the Q&A session. But feel free to ask anything, and then if we don't get to an answer, whether it be in the chat or in the live session, we'll be sure to we capture every question that comes in. We fill out answers for them and post that with the actual recording once we're done. All right, so first up, we will talk about what's new with Niagara. So first, I'd like to just highlight that 4.10 Update 5 is now available. For those that don't know, 4.10 is the long-term supported release that we earmark that version and provide update builds quarterly, so that you can both stay secure with cybersecurity enhancements, as well as any critical defects that have come up from the field that we felt were large enough that we needed to backport and provide a fix for. So it's the easiest way to just stay up to date with a long-term supported release. Now, it's kind of two paths you can take. If you choose the long-term supported release, you're not going to have access to some of the new features that have come out in 4.11 and 12 and 13, but it should provide you, a more easy and stabler path depending on what your schedule needs are. If you have the availability to keep upgrading with the new releases, always recommend it. That way you can bring in all these new features and really provide some value to your customers. And because at the end of the day, that's all we at Tridium try to do, or just provide you all the necessary tool sets to provide you everything you need in order to fulfill customer needs. And now for a good announcement here about 4.13. Again, a good indicator that we're coming up on the release. We are now in the middle of beta testing. We have plenty of candidates who have written into the queue that we're getting signed up, getting the agreements filled out, getting licenses handed out, and we're always happy to, fulfill any other interest of anyone who would like to run 4.13 in a production environment, allow us to ensure that, we have the most stable release, and particularly in the new features, that people can try some of the new items out in advance of the actual release. And we love getting the feedback, learning both, whether or not something, was working for you, even just suggestions to improve upon an existing or new feature. All of the commentary is appreciated. And now we'll talk a little bit about, I guess one of my favorite slides. We tend to put one of these out with each major release, where we highlight those 5 categories I spoke on earlier. And then each of the line items is sort of a individual feature that we're bringing to this version. And I love seeing it all on one slide because it's months, if not a year worth of work, and you get to see all your hard work in one spot. And so today we'll be focusing on multi-tiered system database under the deployment category. But this will be a common slide that you'll see throughout all these Tridium talks, and we'll be showing off some of the other features along the way as we get to the release. But for today's main event, multi-tiered system database. So it's difficult to talk about multi-tiered system database without already knowing what the system database was to begin with. And because of time constraints, I don't want to try to do essentially 2 Tridium talks in one. So I'm labeling this as sort of prerequisite knowledge that would be beneficial to know, to really understand what's happening with the multi-tiered edition, because we're building upon some features that we have built in the past, and we're just sort of evolving them to expand further the framework from supervisor level all the way down to the edge. And so the reason I wanted to make this slide, I know people come back to the Tridium talk and watch these, and so when you see the demo today, there may be some stuff, some knowledge gap that you have, but you can just come back here, and I'm suggesting a couple other talks that we've done in the past when certain features came out. It may be beneficial to go back, refresh your memory, or if it's new for the first time, to learn about some of these things. And the 3 major categories is the system database and its system indexing. And that came out in 4.6 all the way in 2018, which is hard to believe. Niagara virtuals, you're not going to find a specific Tridium talk on, but they are being leveraged here, and as well as in some of those earlier Tridium talks. And so it'd be a good thing to understand what a virtual is versus a typical Niagara Network proxy point. And then we touch on hierarchies and virtual PX views. And the concept is all 3 of these topics leveraged together can provide a much easier workflow when you have scaling requirements. So when you have systems that are just very large, you will find a lot of benefit into following this model for scaling out your larger Niagara Network system. And then the last little note down there at the bottom, the entity model, if you need to go all the way back to when Niagara 4 came out, the underlying concept to all of this is the fact that a Niagara station in Niagara 4 is now modeled to represent a building. And so now we've constructed a data model throughout the components you've already known from AX in your station are now represented in a data model. And for more information, you can look in the developer doc that covers the entity model at large. And that may tie, if you're totally new to it, that'll really tie some and connect some of these dots and tie up some loose ends. So that's some of the prereq knowledge. Again, you'll still learn. If you know none of this to date, you're still going to learn a lot from the demo and the presentation. But this is something to come back and reference and help with cover the knowledge gap later. All right, so multi-tiered system database. So the concept was extending what we've already made to further support larger scaled Niagara setups and systems. So I like the picture on the right a lot. You have essentially two different scenarios, and I'm not suggesting these are the only configurations you can make, and just giving some examples. If we look down the left-hand side, where you have the global regional site building and equipment, starting at the bottom, you may have an Edge 10 running a piece of equipment, and that's got its own Niagara station. You may also have one of our great portability offerings where OEMs take the portability kit and create their own hardware, typically with I/O on it, and that allows them to run a full Niagara station and leverage all the benefits of Niagara all the way down at the edge at the equipment level. So you may have a bus of Niagara stations representing a piece of equipment, and those will get tied to perhaps a single JACE in a building. Again, these aren't hard, fast rules. These are all just the Lego pieces to build whatever you need, and these are just some examples. So say you've got a couple of different buildings that represent a single site, and then maybe you have multiple, and you would have all those JACEs tie into a single site supervisor. That way you have a site level, single supervisor station that can see the whole site, all the buildings, and all the equipment under each. And then if you're really large, you may have sites all around the world or country. And so you may want to split that up by region. And that can easily be done by just providing a regional supervisor that all the individual sites report up to. And then there may even be what often is referred to as a NOC, operation center, or just some head HQ that's got the ultimate supervisor that globally represents every single Niagara station that you have out there, down regionally, site level, building and equipment. The other example on the right-hand side is a common one I think I've seen: equipment floor building campus. So that sort of represents a university, for example. You've got, let's say, a bunch of heat pumps running on a given floor. Each floor has a JACE. There's a supervisor that represents the whole building, and then you have multiple buildings on a campus. So you have a single supervisor up top that represents the whole campus. And so over the years, we've seen plenty of customers build out really extensive networks like this, and which we love to see. And I question if 20 years ago we ever envisioned some of these things would come to play, especially once we got into the edge level devices and portability kit offerings. But it's fantastic to be able to have Niagara at each one of these locations and be able to leverage all the features that exist. And so the system database itself, as you would learn from the prerequisite knowledge, allows you to collect the entire entity model in one location. And in order to do that, it will index down one level and collect all the full entity model and bring that up into a single location. And that allows you to be at one parent station and be able to query that database, and allows you to leverage certain things like hierarchies and virtual PX views. So what we've done here for 4.13 is introduce the multi-tiered aspect. The concept of what I showed on the last slide with a larger architecture. Well, how do you get the system indexer to crawl all the way down to those stations that are all the way down at the edge? And you've enjoyed the redundancy and the flexibility at creating this larger network. So you'd like to leverage the system DB across the whole thing. And so in order to pull that off, we had essentially three components that had to be focused on, designed, and delivered. And the concepts that you'll hear Scott talk about is the reachable station, and of course the multi-tiered indexing, which is the actual system indexer running and then going down through one station to get to the other, and then bringing all that information back up. And then finally, the virtual PX, the ability to import a PX view from the remote station up to the parent. Well, if you have multiple levels, you're going to need that PX view to come all the way to the top. And so for the next segment, I'm going to hand it off to Scott, who is actually going to demo this with a great setup he's configured and spent a lot of time putting together to kind of show it in action. And again, this is a, it's an example. This isn't a hard fast, this is how you do this or configure this. This is just one of the many ways you can leverage this functionality. And without further ado, I will pass it off to Scott.
All right, thank you, Chris. And hello, everyone. My name is Scott Hoy. I'm a software engineer here at Tridium. And assuming everyone can see my screen, Chris, can you see my screen?
I sure can.
All right, good. So I'm going to demo the multi-tier system DB on a simple Niagara system that I have running here. And in this system, I've got 7 stations. So I've got a main supervisor station and 2 regional supervisors, if you will. I'm actually using them as like building supervisors. So I have a west building supervisor and an east building supervisor. These 3 stations happen to be running all on my local PC here for this simulation, but they can be running anywhere. They don't have to be, all local. So they're just running on different ports on my local PC. I do have some devices sitting on my desk here. So I've got 2 Jace 8000s and I've got 2 Edge 10 controllers. So those are connected through these green arrows indicate Niagara Network connections. So in my main supervisor here, I have Niagara Network connection just to my west building supervisor and east building supervisor. I don't have a direct connection down to the Jace or the Edge controller. But through the west building supervisor in his Niagara Network, he's got a connection down to the Jace controller. And then the Jace in his Niagara Network, he's got a connection down to the Edge 10 device. And the same thing on the east buildings here. The other thing that I've already set up and that you will need to set up to use the multi-tier system DB is that I've enabled virtuals on all of these connections. And so that's just a simple true-false setting to turn it on. But when you do turn on virtuals, you do need to set up access control to the things in that virtual space. That's all stuff covered in documentation. I'm not going to go over that here, but it's just a good security measure that when you enable virtuals, set up access control. So that's already been done. I have Fox connections here with these green arrows. And for all of the stations in the mid-tier level, in the top tier, they need to be running 4.13 or later for the multi-tier system DB to work. The edge-most stations, and they don't have to be edge controllers, they can be any Niagara-enabled device, they need to be running 4.4 or later in order to be indexed up into the main supervisor. So in this case, these edge controllers are running 410U5. Another thing to mention is that the station names in a particular Niagara system, you need to be unique so that we can uniquely identify a station based on its station name. And then you could have firewalls set up, that's fine. You could have a firewall here so that the main supervisor couldn't possibly make a direct connection down to the Jace or edge controller, as long as there is some route through Fox, through the Niagara network, that is, down to these stations, they can participate. So I'm going to be doing this demo up here at the main supervisor level. I will just navigate down to this Edge 10 controller real quick. And so you can watch my URL here. I've just got a hyperlink here that's going to take me and let me log in directly to that Edge controller. And the station I've got running there is this name. And I just want to show you the application I have running. So on the Jace controller and the Edge 10 controller, I have like a simulated device down there. So I have an AHU modeled at the Jace, and at the Edge controller, I have a VAV simulated here. So I'm down at the Edge controller in his Edge IO network, and then I've got a VAV device, and this device happens to have a PX graphic, which will load up here, and you can see it's just a simple VAV simulation. This is not connected to a real building, so if the data here looks wrong, it's just simulated data. But this is a graphic that exists down on the Edge controller. It does not exist up on the main supervisor, but what we'll show in this demo is how that PX graphic, along with the components in virtual form, will get pulled up into the main supervisor. So I really just wanted to show that real quick, just to show the setup. So let's go back to the main supervisor. So I'm back logged into this main supervisor here. You can see that's my local host. Before I add in the systemdb, I don't have the systemdb installed here yet. I did want to show a few other little things I've got set up. So this is pretty bare bones setup. I don't have any proxy points. So there's no smoke and mirrors here on these supervisors that are connected to my main supervisor. One thing I have set up already is in the property sheet of the Niagara network under virtual policies, I have enabled this import virtual PX files on demand property. So it defaults to false, but when you set this to true, this will allow those PX files that are on downstream stations to, when they're accessed through a Niagara virtual component, to be pulled up to the supervisor and displayed in the supervisor. And the bindings that are in that PX graphic will get translated into virtual ORD bindings so that they can resolve at the supervisor. This actually will work. The multi-tier virtual PX will work even without installing the system database. The only reason you would need the system database for virtual PX is if you have tag-based bindings in any of your graphics, because the tag-based bindings require doing a query, an equal query, and it's got to go to the system database to do that query if it's for a downstream station. So that's the only thing to keep in mind there. But you could just navigate through the virtual space with this on and get to virtual PX graphics. But I want to show is how you can integrate with hierarchies and search. So I've also set up pre-configured here a few hierarchies, and you can see at the moment if I expand these hierarchies, they're empty, and that's because they're attempting to resolve against the system database, which I have not installed yet. I have a couple tag dictionaries. I've got the standard Niagara tag dictionary and the standard haystack tag dictionary. This is the haystack 3 tag dictionary. So I have tagged up on the downstream stations. I've put some haystack tags on them, and I've put some geo tags on them. Now you could use the geo tags that are in the Niagara tag dictionary or the haystack tag dictionary. I just created my own geo tag dictionary. You don't have to do this, but it allowed me to just imply geo tags on the components in my downstream station. So it's just got a state tag, a city tag, a building tag, and a floor tag that gets applied to all the components. And that just lets me do some hierarchies that are grouped by their location. I do have a couple, so just to show you the hierarchies I've got set up, I've got 2 hierarchies that are example hierarchies. So both of these hierarchies are scoped against the systemdb, and they're scoped by ORD. So this syscolon is the ORed to the system database. Again, I haven't put the system database in yet, but once I drop it in, this hierarchy will start working. The hierarchy I have is a very simple one. I'm just organizing by state, so by the geostate tag, similarly by city, by building, and by floor. And then once I get to a floor, I want to find any equipment that's on that floor. And I'm just doing that with a simple haystack query for HS equip. So that would find my VAVs and my AHUs that I've tagged with the HS equip tag. And then after that, I've got, let me get this a little bit smaller here so you can see it. I've got a child point relation that is underneath that will show, once I've navigated to the equipment, it will show any child points underneath that piece of equipment. So that's the hierarchy that's going to get auto-populated as I index my system. And I have another hierarchy here. I won't go through all the details of it, but it's also going to be organized by state and by city. In my building supervisors on the Niagara Network, I happen to have a PX graphic that shows the building. And then, so I've got a group level element or a query level element for that. And then I've got just the equipment that it finds in the downstream JACE controller and edge controller that I'll group under that along with the child points. So pretty simple hierarchies I've set up. It didn't take long to set those up. So now I want to show, so again, the hierarchies are empty. If I go to search, so if I went to the search service and I typed in a search to find my VAVs, it's not going to find anything yet. And that's because I haven't put the system database in yet. And in fact, there's no scope for the system database yet. So let's change that and show you how quick it is to pull all that information up from my downstream stations. So in the Niagara System Index palette, there is a typical configuration folder, and this has been there since 4.6. So there's a systemdb service that's been pre-configured with some of the common settings that are most commonly used with the system database. So I'm going to add that into my station, and then I'm going to go configure it. So I've got a systemdb service. I do need to tell it the backend graph database to use, and that happens to be the Orient database graph backend. We don't have another backend implementation yet, but that's the main one that we use at the moment. So what that Orient database is going to store is entities, and entities in Niagara typically correspond to components. So entities have tags and relations. So the things that we're going to be pulling into the system database are tags and relations of components that exist in this station or downstream stations. And that's important because those are the things that we can use for NQL queries to be able to query the system. We don't pull in like the real time, like the output values and things like that, but that will resolve when we resolve those things to their virtual components. So you'll see in a moment how we can interact with the downstream stations through the system database. So the next thing I want to do is I want to set up indexing, and that happens through the system index service. And so what the indexer does is he will go out and crawl the system and find all those entities and pull them up into that graph database in the system database. So again, there's a global Niagara Network indexer here. This has been there since 4.6. The only thing new in here is there is a new include reachable stations Boolean property. It defaults to false, but if you set this to true, this will expand the reach of this indexer to go down even further into your Niagara system all the way to the edge to pull in those entities. The way it indexes is it uses index queries, and that there's a list of default index queries. So by default, we're going to find all networks, devices, points, schedules, things like that. You may have more things that you want to index or less things, and you can customize the index queries. So there's a way you can either overwrite this list or add to the list if you want to customize it. For this demo, I'm just going to use the standard default index queries. I'm not going to change those. I'm not going to turn this property on yet, but I am going to go ahead and invoke an index. Now, indexing will happen at a trigger interval. By default, it's once a day, but you can change that to whatever interval is good for you. Typically, entity data is pretty static in nature. Once you've tagged up your systems, they don't change too much. It's not the real-time output values of points, things like that. So let's go ahead and execute this indexer, and you'll see that it went to pending, and it's pretty quick, it's finished. And that's because it only went one tier down. So it only indexed the west building and the east building. And I can also see that by my hierarchies now. One of my hierarchies is going to start to show a few things. It's going to find that east building supervisor Niagara Network and the west building supervisor Niagara Network, but it's not going to find anything after that, and that's because I haven't indexed further down. I've put some display names here so that you can kind of see where these things are coming from. So one of these is coming from the east supervisor, and if I double click on it, it's going to load up this graphic. So this graphic doesn't exist on the main supervisor. It exists on that regional east building supervisor. And in the past, this was as far as you could go. So you may have put in your own hyperlinks to virtual orgs that went further down in the system. But let's see how with the new multi-tier system indexing, where you can get even further down in the system. So let's go back to that system index service, to the global indexer. This is where we were before, and let's turn on that one property. So this is going to say, let's go further down in our reach in the system. So I'm going to invoke the execute action. It's going to take a little longer, about 20 seconds, to go down and reach further down. If you want to see the progress of indexing as it goes, there's a new column on the station manager view. And surprise, there's an HTML5 version of the station manager view on the Niagara Network starting in 4.13. I'm not going to steal the thunder of that, but I do want to point out that there's a new column that you can optionally open. I've already opened this column to display it, but it's for indicating the progress of indexing on the downstream reachable stations that are going through each one of your direct Niagara stations in your Niagara network. So it's already finished now, but it's found that there's a JSON and an edge 10 under the west building supervisor, and there's a JSON and edge 10 under the east building supervisor. So two reachable stations each. And if you were to come here fast enough, you would have seen it go from pending to in progress to succeeded, that it successfully indexed it. If it had a problem, it would go to failed, and you could do some debugging, or if it was ineligible, like if the version of that remote reachable station wasn't 4.4 or later. So now let's see what happens to my hierarchies. So I'm going to close a few of these things. I'm going to refresh my hierarchies, and let's start taking a look. So now my hierarchy over here, that's organized by state and city and building and floor, is starting to fill out. It auto-populated because each time I expand these hierarchies, it's doing a query to the system database, and it's finding that, hey, you have some devices that are tagged with the state of Virginia, the city of Richmond, the building, east building, floor 3, and here's the AHU3 that's coming from the JS8, 8000, and here's the VAV coming from the east building edge 10 controller. And furthermore, if I double click on one, or I go to its PX graphic, hey, here's that PX graphic that actually lives down on that edge controller. It's pulled it up through the virtual on-demand PX. And then now you're seeing live values because these values are resolved to Niagara virtuals. And not only can it find the data, but you can actually command the data. So you can make configuration changes, you can command points, anything you could do with Niagara virtuals, you can do that in this multi-tier system. So that's nice. It's kind of auto-populated my hierarchy. The other thing is, if I go back to search, I'm going to open up the search sidebar here, but you can go to the search service, and I enter in that search for HSVAV. Oh, it didn't find anything because I need to change my scope. If I just tell it to search against the system database, now it's going to find those two VAV controllers. And so I can click on one, and again, it's going to take me to the PX graphic. So it's enabled search and hierarchies to be able to find stuff all the way down in your Niagara system, and then be able to resolve them to Niagara virtuals to be able to do command and control of those things. So that's the main part of the demo there. Before I end, I do want to talk about some of the underlying technology that's enabling this, because those things may be used in future applications. So when it went out and crawled the system to find the reachable stations, it actually, I'm back in my Niagara network, I'm a main supervisor under one of my West Building supervisor Niagara stations. There is a sysdef device extension that has been there, but underneath that, there's a new reachable stations container. And this is where we stash away information about the downstream reachable stations that were found through this West Building Supervisor route. So it found the Edge 10 controller and the JACE 8000 there. And this is nice because this gives us some information that we need when we want to make, a connection to those reachable stations. One thing you may be familiar with is in-space awards. And in-space awards are used kind of under the covers with the system database, but I know that we do have some customers that have been using them in PX graphics. I'm going to manually type in an in-space award into my URL here. It's not something you typically do like this, but you may have some in your PX graphics. I have typed in an in-space award, and then the name of the station that I'm telling it to go to is the Edge 10 controller, which is a couple hops down. I'm still connected to my main supervisor here, but I'm going to resolve this award and see what happens. What this does is it says, okay, let me find a reachable station that matches this name and resolve to the virtual space for it. So now I'm still connected to the main supervisor, but I can navigate the virtual space for that edge device. And I'm getting down to the edge network. And then here's that VAV device that's in that edge network. And again, I can go to the graphic, same thing. It's loading the virtual PX for that VAV controller. So that's cool. And then the last thing I wanted to show for you super users out there is there's some new SPY pages. So this is not something that typical users would go to, but if you're a super user and you're trying to do some debugging, these tools can be helpful. So in the main SPY under Niagara Network, there's a new reachable station SPY, and it has a few options here. I'm not going to go through all these details, but basically it lets you open up a debug view of like your Niagara station routing table, if you will. So it shows you all of the reachable stations that you can reach, some information about their versions, the path to get to them. There could be multiple paths, routes to get to the same station. So it will detect that, and it will be smart enough to pick the optimal route to get to a station, meaning it'll pick the one with the fewest hops to get there or the fewest time to reach. And it can also detect like circular paths and circular routes so that it will prevent any infinite loops and things like that. So if you're trying to debug your reachable stations, there is a view that will let you see all of them here. And then the last SPY tool I wanted to show is that you can now get an in-depth look into the system database itself. So that Orient Graph database, you can navigate into it and see everything that is indexed into the database. So you could kind of do this before by doing a search and you could see what was in it, but you couldn't see all of the tags and relations that it had pulled into the system database. And this view will let you see the tags and relations that those entities have that are in the system database. And it can also, if you're trying to figure out the index queries that you want to do so that you're not pulling in too much information from your downstream stations and just filling up your system database with a bunch of components you don't need, you can use this to kind of see what's in there. Do I have too much? Do I have too little? And then you can tinker with the index queries to get, what you need. But again, this is a super user view, and it's just something to help you identify, debug issues. So that's it. That's all I was going to demonstrate here. I'm going to hand back over to Chris, and then we will try to have some time here for some questions. Back to you, Chris.
Yeah, thank you, Scott. Great job. Excellent demo. Again, it covers a lot, obviously. Given there's some prerequisite knowledge, if you're new to some of these concepts, I have no doubt you'll be coming back to rewatch over and over to really wrap your head around everything. I think one of the biggest takeaways for me is, and this isn't just from multi-tier, but just this style of creating a supervisor or a parent supervisor. The concept of creating the station one time and then not having to, the old style was to discover all the points in the Niagara Network and redo the graphics up at the supervisor level. I love the idea of I've done the work already, whether it be at the edge or at the JACE, and now I can just see that the proxy representation of that station up at the supervisor. And so these are just tools that help leverage that workflow and really enjoy seeing the evolution of the framework for scalability purposes. So I'll try to go kind of quick here at the end so we can get to Q&A, because there's some couple of great questions in there that I want to go through. So we'll cover real quick Niagara resources and materials. I threw this slide in there just because I really like here's our roadmap, the timeline. You find this on the website all throughout all the years, how all the versions have come out. Also on the website, there's, highlighting each of the features that have come out with each of these versions. So you get a better picture when you go to that page to see, how the framework has evolved. And this has already been answered in the Q&A, but just wanted to touch on, we have a Tridium University website. This is where you can sign up for training. There's some free online training and additional resources that can be found. Tridium University and the Niagara community website, they're all ingrained. So you make one account, and all you need is an email. It's free. You get access to both the forum. If you are already a partner, that's where you get access to licensing, and then the Tridium University page as well is full of all sorts of great content. Real important topic here. This is where you can find, once we post this and the additional ones, like the ones I showed off, previous Tridium talks. Go to the tridium.com, services and support, events, and you get a nice search to help you kind of dig through all the different Tridium talks we've posted over the years. And we're really enjoying making these, and we're actually evolving to make different types of series. So there may be plenty of videos up there that may not be relevant, and then some that are more relevant to your area. But generally speaking, I think there's a little bit of something for everyone that you can find on the events page. One last great thing we always like to chime out. We do have a YouTube page, and we've seen some really cool presentations from Kevin Mamajak and James Johnson, some veteran sales engineers. And now finally, we roll into Q&A. And I'd be happy to actually go ahead, Blake, and I can kind of take that first one about, there's sort of a question about trying to figure out which version needs to be 4.13 and which version needs to be 4.10. The thing to remember is that the reachable stations doesn't exist until 4.13. So for a lack of a better word, any station you're kind of routing through, that has to have 4.13. Now the item that's at the end of that chain, that could be 4.10 and can be brought up. But if you have multiple tiers, only the bottom could be like an LTS version. And one of the greatest benefits to that is a lot of the portability offerings stick with an LTS version because it's just an easier scheduling workflow. And so you may have a lot of edge devices running Niagara at the edge that's 4.10. So it's just a great sort of a great thing that you don't have to upgrade everything to 4.13 to make this work, but you will just keep in mind anything you got to route through that needs to be 4.13.
Yeah, and just to point, those last edge devices, they can be 4.4 or later. They don't even have to be 4.10, but any of the stations in between, they do have to be 4.13. So in order to know how to route the information up, those things need to be 4.13. But once you get to the last destination station, it can be 4.4 or later.
Yeah, great point, Scott. It is, we're always encouraging people to keep moving forward, but I fully appreciate, having been a contractor myself, that it's about budgetary and scheduling. So if you're not quite, off of 4.4 yet and move to 4.10, but you're planning on it, you could still leverage this all the way down at the edge. So Blake, what question should we pick from next?
Yeah, I have another question here about the system database and where various things are supported. Does the system database and this new functionality currently only work on a JACE, or does it work on a JACE or just a web supervisor?
So it is the system database is only for a supervisor, so it's only licensed for supervisor platforms. But you can have intermediate JACEs that aren't running the system database, but that can be used to, like, be the mid-tier hop that lets it route the information up from downstream stations. So those don't need to have the system database installed, just that, supervisor at the top. Now you could, in the demo I gave, you could actually run the system database in those two east building supervisor and the west building supervisor and the main supervisor, but I did not have the system database installed on the two regional supervisors. I only had it installed at the top. So, and that does need to be a supervisor platform.
Okay, and if I have any custom or unique modules installed on some of the JACEs down at the edge, do I also need those installed on the supervisor in order for this to work?
I think it would be a good idea. The virtuals may resolve even if you don't have them installed. I'd have to double check, but typically supervisors are going to have all of the modules because they have plenty of resources. So there's no reason to like not have the modules up at the supervisor that you have on the downstream JACEs and edge controllers. So I think most often you will have those jars already up there. I don't know that it's required, and especially the guys that are just the intermediaries that are just routing the information up. I don't think you need to make sure that they have the same necessarily modules installed. But the topmost supervisor, I'd have to double check that. But I think you may not have to have that, but typically you would, because most of the time supervisors have all of the modules available to them.
Okay, we have a couple of questions about performance. So compared to using export tags, how does using the system database perform?
So I think that's probably related to the virtual PX, because export tags allowed you to kind of pull up PX files. It's very similar to, in fact, both export tags and the virtual PX are using the same code to pull the virtual PX files up. So they're gonna perform the same. One thing I didn't point out during the demo that I meant to talk about is that you may actually find that the virtual PX load faster. And the reason for that is that they are being served up. So when the PX files flow up, they get cached on that supervisor that you're connected to, and then they're served up from there. So since a supervisor is typically running on a higher end server that has more resources, it may be faster to load than if you were connected directly down to that Edge 10 device and loading a graphic from there. Now, that's the initial load of that view and the graphics on it and everything. It still has to resolve the bindings in that PX graphic, and that needs to resolve to virtual, those are virtual ORDs. So that there is some time it takes to resolve the bindings, but you may find that your virtual PX views are a little snappier than connecting directly down to the edge controller. But between the export tags and system database, well, it's really not the system database, it's the virtual PX views in that case, there shouldn't be a difference because they're using the same underlying code.
Put any on those JACEs or supervisors at the mid-tier?
I lost you there for a second. Can you repeat the question?
So for the JACEs or supervisors in the middle tiers, does using the multi-tiered system database add any additional load to those systems?
So that's a good question. Under the covers, it's really just routing Fox messaging. So it says, hey, I got this request, but this request is actually for a downstream station. So it's just going to pass that Fox message down until it gets to the destination station, and then the response will also get passed back up. So it's not a huge burden to those middle guys. Yes, they're doing a little bit of work just passing, network packets around, but it's not like it's caching, system data, the entities and things like that at all the middle tiers. They're just a pass through of the information as it's coming up to the main supervisor. So there shouldn't be much load on there other than a little more CPU time during the indexing while it's processing these network commands that it's getting. I think that's.
Okay, no, that's great. We have a number of questions about, I guess, using virtuals in general. If you don't mind answering some of those. Can you use virtuals to view the web wire sheet on the edge devices?
No, that's a good question. So virtual components they're different than normal components. They don't give you all the views that you have on other, normal components. So they cannot be used for things like links, because virtual components are only live in the station on demand as they're needed, and then they'll go away when they're no longer needed. So they're more memory efficient than normal components, because normal components and proxy points and stuff like that, they're persisted in memory for the duration of the station. But virtual points only get created on demand when they're needed, and then when they're no longer needed, they'll eventually go away and get cleaned up from memory. So they couldn't support links because they're transient in nature. So the wire sheet is not available on them. The property sheet is available, so you can go to the property sheet of virtual components and you can make changes to configuration properties that way. And then the PX graphics will work. But there are some views, like if you have custom views, that will not work. Now we do have some support for other views. For example, there's an HTML5 scheduler view that does work on a virtual component that represents a schedule that's down on and I didn't show that in the demo, but if you have a schedule that's down on the edge controller, you can go to its HTML5 scheduler view over the virtual component of that and make changes to it. But not all views, including the web wire sheet, are available. So, there are some limitations to what you can do with virtuals.
So a couple of questions that have kind of come in, and I just wanted to clear up. So there's questions like, does this reach BACnet Modbus LAN network devices? And so one thing you want to be mindful of is, no, but that's because this is all focusing on the Niagara Network driver. So your BACnet device is not necessarily running a Niagara station. However, you have likely brought that BACnet device into a Niagara station, which creates the proxy representation of a BACnet device. And so in that regard, once you've brought that into a station, yes, you absolutely get to see that. So if you have down at a Jace, you've got the BACnet network, you've brought in your BACnet devices there, you've created a PX view of, say, the VAV BACnet controller on that component. Well, anything that exists in that station as a component is now can be seen through virtuals, and then in that regard, it applies.
Yeah, and actually in the demo, the AHU devices I had were BACnet devices. So yes, once you pulled it into a Niagara station, it is available.
So we have a number of questions about what you can query from the system database. One is, can I run a query for all the overridden values in my system? And then we have a couple about, can I query alarms or histories through the system database?
Good question. So the system database, again, it stores entities which have tags and relations. And typically tags are static in nature. So it's describing the device, or it's describing this is a point in a device and these are the tags for it. So things like the current value and things like that, while some tag dictionaries have that as a tag, when you're querying the system database, it has not been refreshed since the last time there was an index that occurred. And furthermore, when indexing occurs, it does not force a subscription on those downstream points. And so those downstream points, when they get subscribed, that's when they may start polling over BACnet or whatever the protocol is to actually get real values. So so the answer is, like, can you know, like, about if it's points are overridden, find all the points that are overridden? No, because there's not a reliable tag that you can use to query for that. So, the system database is used to, we can resolve NQL queries against the system database. Now, once you resolve an equal query against the system database, you could pipe a BQuery query onto the results of that, but going directly against the system database, it's an equal query. Now, alarms and histories, no, those are separate. So if you're trying to do like exception, like I want to find the points that are in alarm or in things like that, that's where the alarms are different, because alarms do get routed up, as soon as they occur down on the edge controller, assuming you've set the system up right, they will route the alarm up to the next top, which will route it up to the supervisor. So that's a separate use case. So you could get notified of your points that are in an exceptional condition, but that's going to the alarm database, which is a different database. It's kind of solving a different problem. It's a time series database versus the graph database that backs the system database. So the system database is nice if I want to find a thing like a point. I can go find the point, and then once I found the point, now I can go to its history. So we don't query the system database to find a history. We go to the system database to find a point, and then from the point, it has a tag that says my history. It might have like an in history tag that says my history. Oh, by the way, my history happens to be this history by this history ID. And you can from the point go directly to the history chart view, for example. So you're not, histories are actually metadata about a point, really. So it's not the other way around. You don't use the tags to find a history and then go to the point. You use the tag to find the actual thing, the device or the point, and then you can find its histories or its alarms or things like that. Once you've resolved that virtual component, it will tell you if it's overridden or in alarm, but the query itself is based on the tags. So I hope that makes sense.
I think it does, but if I were to query maybe the configuration, such as the configured high and low limits of an alarm, or just I want to know which points have alarm and history extensions on that, I could do that through the system database, correct?
Yeah, as long as there's tags that say, hey, this thing has an alarm extension or this thing has a history, yes, you can. If they're in the form of tags or relations, then yes, the system database does know about that.
All right. Well, we still have plenty of questions in the chat, but we have fallen short on time. And I appreciate everyone's participation and questions. They're great, and I promise we collect everything that gets typed here. We will get answers for them and get that posted when we post the video. But thank you both, Scott and Blake. Very great job, Scott. Very well done. I know that's arguably years worth of work that has brought us to this moment. So excited to share this with everyone in the community, and look forward to seeing what everyone can create with the enhanced flexibility that we've provided. Well, thank you all very much for joining us today, and I hope everyone has a good rest of the day, and stay tuned for the next one.